Have you ever been staring at an algebra problem and that tricky little x is on both sides of the equal sign? You know the ones. It's a super common hurdle, but by the end of this, you're going to have a simple, foolproof method to solve it every single time. Let's jump right in.
So here's our game plan. First, we're going to look at this whole thing like a puzzle. Then I'm going to share a really simple rule to solve it. We'll walk through some examples together, and I'll point out a couple of common traps to watch out for. We'll wrap it all up by applying this skill to a real-world problem, taking you from confused to totally confident.
So why is having variables on both sides of an equation even a problem? Well, think about it this way. To solve for x, you need to get it all by itself, right? But you can't really do that if it's hanging out in two different places at once. We've got to get all the x terms on the same team.
This really hits the nail on the head. Imagine the x terms are your puzzle pieces, and that equal sign in the middle, that's like a wall between two different rooms. Our first job is to get all those pieces into the same room so we can actually put the puzzle together. Here's the classic example. You see it, right? We've got 5x on the left and 3x over on the right. They're separated. Our goal is to unite them. But how do we do that without, breaking the rules of algebra? Well, that brings us to my favorite part. So how do we get them on the same side? I'm going to let you in on a simple but really powerful strategy I call the move the guy rule, and it's designed to make solving these equations so much easier.
Okay, so the key is this. Always find the smaller variable term, the little guy, and move it over to the side with the bigger one. Now, why do we do this? It's simple. This one little step helps you avoid working with negative numbers, which, trust me, is where most mistakes happen.
And here's the proof right here. On that top path, we move the smaller term, the 3x. Notice what we end up with? A nice positive 2x. Easy. Now look at the bottom path. We move the larger 5x, and suddenly we're dealing with a negative 10 and a negative 2x. You'll get the same answer, sure, but it's a much messier road with way more chances to make a mistake. Let's stick to the easy path.
All right, enough talk. Theory is great, but let's actually see this rule work its magic. We're going to walk through a few examples from basic to a little more advanced to really make sure this concept sticks.
Let's start with the problem we've been looking at. 5x equals 3x plus 10. We know our goal. Get those x terms together.
We're going to follow a simple two-step process. First, we'll use our move the little guy rule. Then, once the variables are all on one side, we'll do one final step to get x all by itself and find our answer.
Okay, step 1. The smaller variable term is 3x. To move it across the equal sign, we use the inverse operation, which is subtraction. So we subtract 3x from both sides to keep the whole thing balanced.
And just like that, the 3x on the right is gone. And on the left, 5x minus 3x simplifies to 2x. And look at that, all our puzzle pieces are in the same room. The hard part is already over.
And now for step 2. To get x all alone, we just divide both sides by 2. 10 divided by 2 gives us our final answer, x equals 5. See? Clean, simple, and absolutely no negative numbers.
Let's try another one. This time, the little guy, 2y, is starting on the left, but the rule is the same. We move it by subtracting 2y from both sides. That leaves 15 on the left and simplifies to 5y on the right. One last step. Divide both sides by 5 and we get our answer. Y equals 3.
Okay, but what if one of the variables is negative? The rule still works. Negative 4k is definitely smaller than 6k. So to move it, we do the inverse of subtraction, which is to add 4k to both sides. On the right, the negative 4k cancels out, leaving 10. On the left, 6k plus 4k becomes 10k. Now we have 10k equals 10. Divide by 10, and k equals 1. The rule holds up every time.
Now that you're getting the hang of it, let's talk about a couple of common pitfalls. Because honestly, knowing what not to do is just as important as knowing what to do.
First up, if you move a term and it's the only thing on that side of the equation, you can't just leave it blank. You're left with a 0. Second, you have to remember to use inverse operations, adding or subtracting, to move terms across that equal sign. You can't just slide them over. This first point is so important, it gets its own slide. If you subtract 3x from 3x, you don't get nothing. You get 0. That side of the equation is now equal to 0. It's a real number, not an empty space. Do not forget it.
Okay, so we've solved for x, y, and k. But you might be thinking, when will I ever actually use this stuff? Well, let's connect this abstract skill to a practical problem you might actually run into. Imagine you're choosing between two rental car plans. Plan A is a flat $50 a month. Plan B is cheaper per month at $30, but it's got a $100 one-time fee. So which one is the better deal? The answer? Well, it depends.
To figure out when the costs are exactly the same, that's the break-even point, we can set up an equation. Let's say M is the number of months. The cost of Plan A is 50 times M. The cost of Plan B is 30 times M plus that $100 fee. And would you look at that, it's an equation with variables on both sides.
And now we know exactly how to solve this. Let's use our rule. The little guy is 30M. We subtract that from both sides. On the right, it cancels out, leaving just 100. On the left, 50M minus 30M simplifies to 20M. Our new clean equation is 20M equals 100.
One final step. Divide 100 by 20, and we get 5. This means at exactly 5 months, both plans cost the exact same amount. So if you need the car for less than 5 months, Plan A is cheaper. But if you need it for more than 5 months, Plan B is going to save you money.
And that's really what this is all about. This isn't just about solving for X on a worksheet. It's about having a tool to compare phone plans, gym memberships, or any scenario where you need to find that critical break-even point. It's a method for making smarter decisions. So, what other puzzles will you go out and solve? Thanks for watching.